Hello, everybody. Hi, I'm Phil LaMarr, and welcome to NASA's Ask the Astronomers Live, the show where we bring actual scientists, not cartoon ones, here to answer your questions about the universe. Now, if you want to find out about upcoming shows and see lots of fun astronomy videos, go ahead and visit our Universe Unplugged website, universeunplugged.org. And there you can ask questions of our scientists in the comments section. And if you do, make sure to include your social media handle so that we can credit you properly on a show like this one. All right, today we're going to be talking to a couple of astronomers who convert images into sound in a process aptly called sonification. Let's find out more about sonification, but first, let's find out about our guests. We are joined today by Dr. Kim Arcand, who is a visualization scientist from NASA's Chandra X-ray Center at the Harvard-Smithsonian Center for Astrophysics. Hi, Kim.
Hi, it's a long one. Thank you for having me here today.
Thank you for coming. Tell us a little about yourself.
Sure. Well, when I was a kid, I kind of wanted to be every kind of scientist you could imagine: environmentalist, doctor, veterinarian, you named it. But what I realized is I was actually really attracted to computers and being able to use data to essentially talk about science. So I essentially get to spend my days just doing that, using data of the universe to be able to tell stories about that data based on the science. And that story might take the form of a two-dimensional image. It might take the form of a three-dimensional model, or perhaps a data sonification.
Ah, so you are a Renaissance woman.
Sure, I'll take it.
Well, today we are also joined by Dr. Matt Russo, who's an astrophysicist at the University of Toronto. Hello, Matt.
Hi, Phil.
Matt, tell the folks a little about yourself and your work.
Sure. So I'm an astrophysicist. I teach at the University of Toronto, and I'm also a musician. And so for a while, I've been calling myself an astromusician. But to be more technical and precise, I'm a sonification specialist. And so I work in astronomy, which means I'm finding a way to listen to the rhythms and harmonies and really any kind of data we can get about the universe we live in.
Wow. So you're taking the data that scientists, get from the universe and converting it into music? Not just random clunks and
sometimes random clunks, but also sometimes music. And it's kind of up to the listener in some cases.
Random clunks can be beautiful too.
It's some sort of Flintstones. Well, now usually when I'm talking about sonification, which I do more frequently than one would think, I like to start with, what is sonification? Kim?
Well, in its simplest form, data sonification is essentially just the process of translating information of some kind into sound of some kind. But I think what might be helpful for the conversation is just to take a quick step back. So if we look at our first slide, we can see that essentially when we're trying to understand the universe, when we're studying all of those things around us, these incredible cosmic and celestial events, there are all different types of light that we can do that in. We can use X-ray light, we can use infrared light, we can use optical or visible light, and we could use ultraviolet light. It really depends on the questions that we're trying to ask. But what that means is most of the light, most of this information that we're getting of the universe is actually something that we can't see with human eyes. Even if it's optical or visible light, that light is typically magnified to great lengths using very special pieces of equipment, such as the Hubble Space Telescope, in order to get that information. So in the next slide, you'll see that when we get our information, we have to translate it in some form. In this case, we're looking at Cassiopeia A, which is the remains of a star that exploded about 10,300 years ago. And we're looking at that now as a two-dimensional image, but even that process, getting to this step here, has taken some translation. And then we go further in that process of translation, if you will, and see it in full color, because we've been able to add color to that image to be able to pick out the various chemical elements that are part of that expanding bit of remains of the star that exploded. But at the end of the day, we can do much more with that. when we have really special data, we can take it and we can create, for example, a 3D model, which we see in our next one. This is just a very quick glimpse of that. And then, again, once we have it in some other form, we can take it and translate into something else, like, for example, data sonification. The point is we're getting all of this data, right? And it's just really at its very simplest form, a series of ones and zeros. So it's up to us to be able to decide what kind of output we would like to make of that information. And that output could take many different forms. It could take the form of a 3D print. It could take the form of a virtual reality application. It's all about being able to translate information of our universe into some form that we can't see naturally with our human eyes into some other output that makes sense for the science.
I see. Okay. So you're not just randomly doing it just because you can.
Right.
The colors help us understand it on another level. Because I have to say, that image you had of Cassiopeia A is definitely a lot more interesting than some immense Excel spreadsheet.
Exactly. And these are all steps, right, in a process of translation, and we're making choices along the way. But as you said, we are using the science to guide us, right? It's not me just having a bad day thinking, oh, I'm going to make this image blue because I feel blue, right? There really is I guess I could, but there really is a point to it. There really is a point to the process and a reason for making that translation from one form into another, because we can't see it in its native form, if you will, anyways. So we have to do that translation. And we're humans. We have our own experiences and perspectives, of course, but we use the science to essentially guide us to one of those outputs.
Oh, thank you for those slides. Matt, you had some slides as well, right?
That's right. So the first one is an image that we're going to listen to today. So this isn't actually one image, it's actually three combined. So this is what happens when you point three telescopes, so they're Hubble, Spitzer, and Chandra, at the beating heart of the Milky Way. You point those telescopes right at the core of our Milky Way galaxy. And they all record different types of information. And here we're seeing it in a visible form. They're all kind of layered on top of each other. But today we want to listen to this data. And so since we're taking two-dimensional data and we want to listen to it, we have to make some choices. So the first one is, how are we going to evolve through it in time? And so in this case, we're going to let time flow from left to right. We're going to scan across. And to hear the different shapes and structures in the image, we're going to let the pitch of notes go from the bottom of the image to the top of the image. So bright lights near the bottom are low notes, bright lights near the top are higher notes. And then the actual brightness of the light or the radiation that we receive is going to make the sound louder. And so with those choices, we're going to listen to a sonification that has all these three layers. So there's optical light, there's infrared light, and there's X-ray light, all combined into one kind of symphony. They're each playing their own instrument, playing the same song.
Got it. Wow. The literal music of the spheres. That's amazing.
Yeah. And we can dig into each of the layers, and I can kind of show you what we were seeing and hearing in those.
Oh, okay.
So on slide 6, we're going to see, this is Hubble's image of optical light. So this is closely related to what you would see with our own human range of sight. And so there's arcing bands of really dense clusters. So this is where stars are forming, and they're heating up the light in these kind of arcing bands, and those created kind of slowly moving pitches through the image. And the punctuated notes, which were a plucked string in this case, are individual bright stars or really bright sources. So that's the optical light. And we also, in there, we listen to a bit of the infrared light. And this one's much more diffuse. It's much more cloudy looking. Those are clouds, giant clouds of dust is what we're mainly looking at. There's a lot of gas there too. And those are clouds that will eventually, some of them will eventually form into stars. And finally, there's the X-rays. So there's some very bright sources here, which are extremely hot stars. And there's also this diffuse gas, which is extremely hot gas, particularly in the bottom right of the image. So that's near the end of the music we heard. And that's where the center of our galaxy is. That's the activity surrounding our galaxy's supermassive black hole. So it's a very violent and energetic place. And that's why the music kind of swelled there as a crescendo.
Oh, interesting. That's fascinating. The decisions you make to help, make that stuff, like you said, the string instruments were the stars. That was a choice on your end?
Yeah, there's a lot of artistic choices here. It's always a balance. In some cases, you want to go more or less in one direction. In that case, we decided that strings would communicate the information in the visible image, and then other instruments, so I think it's a piano and a glockenspiel, would communicate the information of the other instruments, the other telescopes.
Wow, that's great. That's amazing. Well, now I have a couple of questions for you guys. Because I'm looking at this stuff and it's so beautiful and fascinating. And I'm curious because I have to admit, I had never heard of sonification before this. How did you become interested in sonification? Kim, can I ask you that?
Sure. I mean, I think for me, I've always been very interested in what can we do with our data. I love two-dimensional images. I think they tend to be things of great beauty, but this data that is inherently visible to us for the most part anyways, it can take so many forms. So do we always have to privilege just that one form that so many of us are familiar with? What other modalities, what other outputs are useful to other people? And what other experiences, who else for our audience can we consider when we are creating these means of expressing the data, the science? And so I think that's always been a bit of a driver for me anyways. And I think particularly during the pandemic, it's been difficult working with some of the audiences and the communities that I've been used to working with in non-pandemic times. And because we can't get out into the communities as much as we were, and we can't do the types of programs that we were, Data Sonification offered a new way to communicate with people. And particularly, for example, people who are blind or visually impaired that are not going to be able to see a two-dimensional image, right? Like I can. And how can we take that information and extract just as much value for someone who has a different means of exploring the world or the universe?
Wow. So you're like the painter who said, "Why don't I sculpt something?"
Yeah, I guess so. Yeah, thanks. You're really handing out the compliments today.
Matt, how about you? How did you get started in sonification?
Well, I've always been really passionate about music and astronomy, and it's actually a source of great conflict for a while because I had this really stupid idea that I had to pick one of those two fields. And since I couldn't make a decision, I just didn't. So I tried to do both for as long as possible. So I did a degree in jazz guitar, and at the same time I was taking astronomy courses. And then when that was done, I did an astronomy degree, and then I was playing music in a band on the side. And then at the end of my astrophysics postdoc, when I would really have to make a decision, what job are you actually going to take? How are you actually going to bring in some money? And what are you going to do with your life? Right at that time, they discovered a very musical solar system called TRAPPIST-1. And I decided to find out what it sounds like. And that began my foray into sonification and my exploration of the universe through sound. And it's been so exciting and rewarding, and I've never looked back.
Wow. That's such a great story. It's funny. It reminds me of when my son got into NYU, there was another girl who was trying to decide between going to college for astrophysics or musical theater. So I'm praying she discovered sonification.
There's probably some other avenues too.
What do you guys think is the potential impact sonification can have on people? Kim, have you thought about that?
I have a little. I mean, I will say the response to the data sonification pieces so far have been pretty tremendous. I mean, just our website alone was receiving a lot of visitors, and the pieces on social media had millions of views and many tens of thousands of likes. And that was just an absolute pleasure to see. But I think much deeper than that, the work of Dr. Wanda Diaz has really inspired me to think more deeply about those potential impacts. She is an astronomer and a computer scientist who lost her vision as a teenager. And she got her PhD in like a human computer interaction type of area, where she actually studied how astronomers could learn to be better listeners so that they could use their sense of hearing in order to understand the universe in a different way. And her research essentially showed that you could learn to be a better listener, that we could all potentially learn to be better listeners. And I feel like particularly today, that's a skill that I think is worth having. So this idea of data sonification as another way of knowing our universe, which in essence is another way of knowing ourselves, I think it's just something very worthwhile to explore. And truly, it's something that many cultures have done throughout all of civilization.
Right. Wow. I mean, obviously, sound music predates technology, but now you guys are using technology to take it to a whole other level. Matt, I mean, as a musician, as a scientist, why do you think sonification resonates so much with people?
Well, it's a good choice of words, resonates. There's a few reasons I can think of. I mean, astronomy it's thought of as a very visual field. And so people seem to get really excited about experiencing something from a new perspective. You know, you can really sonify any image you want, but there does seem to be something about sonifying astronomical images and data that really gets people going. And maybe it has something to do with this idea of these being two human universals. You know, every culture through time has had music. Every culture through time has looked up at the sky and tried to understand our place in the universe. And so this kind of connects those two ideas. And I think it might help people have a more personal and intimate connection with something that's usually thought of as being very distant and remote and inaccessible. So I think that personal connection that you can get through sound really helps.
Got it. Wow. That's amazing. Now, how has sonifying astronomical images changed the way you view other non-astronomical images? Is that something that you've noticed, Kim?
I think that's a fair question. I think for me, data sonification has just opened up more pathways to knowing, as I think mentioned earlier, that there's not just one way of knowing, right? And so what is the potential to be able to harness other senses in order to understand more in any field, in medicine or microscopy or literature? I mean, there are, I think, many ways of understanding and learning and knowing. And that I think is really a pleasure to be able to explore. I think for me personally, it's just yet one more tool in the astronomer's tool belt to be able to capture that information of the universe and communicate with other people in new and interesting ways, including other scientists. So again, there's just a lot of potential for exploration there.
Wow. That's funny, because you made me think about the fact that when you have students in a class, generally speaking, you say, pay attention, that means look forward.
Mm.
But really, we want people to look, to listen, feel. All your senses are used in learning and understanding.
Yes, I love that, actually. Just I have to like do a quick segue. When I was learning how to drive many, many years ago, I think one of the best lessons from my father was to use all your senses when you're learning how to maneuver on the roads, right? And it's something similar here, that you don't have to just privilege one of your senses when you're trying to understand something or trying to communicate something. So yeah, memory lane. Apologies.
Well, and for anyone who is just joining our show or missed the beginning, we are talking with Dr. Kim Arcand and Dr. Matt Russo about the sonification of astronomical images and how both of them came to be involved in this. But right now, let's take a look at an audience-submitted sonified image. Do we have that, Keith? Matt, you made that?
Yeah, I did. It was a lot of fun, actually. So
beautiful.
Yeah, that was submitted by Joe Chavez. So thank you very much for that. That is a different view of the plane of our Milky Way galaxy. That was also an infrared light using the Spitzer telescope, looking at a different part of the Milky Way at the light we get from right around the midplane. And so there were kind of looked like waves of dusty clouds and some very bright stars and some nebula in there and star forming regions, all kinds of things. There's a whole treasure trove in that image and hopefully in that sound as well.
Wow. Now, do you look at the image and play the stars like notes, or do you program it to say, anytime this is there, this is the sound that's going to be made? That's just a question for me.
Yeah. So it's a process. I'm coding to do this. So I take the input data and I'm making choices about which parts of the data gets translated to which musical aspects. So in this case, I chose the musical scale, which gave the overall harmony. So that was an artistic choice to convey the information. And I chose the range and maybe how fast it crosses over and a few other basic parameters. And then you just kind of press play and see what comes out.
Excellent. Wow. Now, we actually have an audience question. Tracy Prell wants to know, what specific additional information can you learn from sonification versus just from optical information?
Well, that is a really great question, Tracy, and thanks so much for sending that in. I think what's interesting is the human sense of hearing has a lot of potential to be able to distinguish among noise. So there are definite, very real instances when you're using data sonification in the research side of things, where you can actually pick up better information among a larger pile of noise, so to speak, than you can when you're just looking at that sort of information represented visually. And that's a sort of question that I think we really need to explore more. What are the opportunities for scientists and non-experts to be able to learn more, extrapolate more information by using this technique of data sonification? So yeah, it's a really great question.
That's great. Let me ask you guys, do you have, now you guys are sonification specialists, this is what you do, and I'm sure you've looked at thousands of sonified images. Do you have a favorite? Matt?
It's a tough question.
Probably impossible, but I'm asking it anyway.
Sure. If I had to pick one out of my my children of sonified images. I know that you shouldn't do that, but if I had to, it's always the last one that I made. So in this case, it's the it's the
See?
pillars of
Sophie's choice
creation.
wasn't that hard. Just take the baby, Sophie. Take the baby.
Well, that's what I'm doing. Yeah, I'm taking the baby with the pillars of creation. That's the last one I worked on, and I've always felt really connected to this image when I first saw it in high school. It's just one of the most iconic images I've ever seen, and so it was really exciting to have the privilege to find a way to hear that for Chandra.
Wow, amazing. Kim?
Oh, yeah. So like Matt said, you're not supposed to, I think, pick a favorite child. But since you asked, I do have to go with Cassiopeia A, the remains of the star that exploded. And I think the reason is this image is very near and dear to me because it is one of the very first objects that NASA's Chandra X-ray Observatory ever looked at. And it's very important for Chandra scientifically and also engineering-wise because it's a target Chandra looks at over and over and over again to make sure everything is sort of like in good working order. So I have been looking at this data since 1999. And, that started from a very early short exposure 21 years ago to now being able to hear it. And I think that first time that I heard the data that I'm so familiar with, it really was an almost overwhelming experience to be able to navigate that information in such a unique and, to me, beautiful way. So yeah, Cass A, that's definitely my choice.
Wow. Well, I have to say that's a fairly appropriate choice, Kim, since we're approaching Halloween. You've just picked the image of a dead exploded star. That's basically a ghost.
Yes.
That is.
It is.
Astronomical ghost, because a ghost which you can see and hear.
Exactly.
Now, I don't want to get, too spoilery, but what images are you guys thinking of sonifying next? If you can tell us.
Okay. Well, no, I think
us.
This is a great question too, because I think it is important to just mention that we're not picturing this as just a one and done kind of project, that we are really hoping it is something serialized, building a library of sorts to be able to expand on these forms of data. So we are working on an object that is very large, one of the largest gravitationally bound objects in the universe, if that offers any hints. Matt, do you want to follow up with that?
I think that's enough for now, but I want to, we'll keep it under wraps, but I want to just flip the question and say, what image are you going to sonify next? Because there's actually ways that you at home can sonify things in your web browser very, very quickly. So we're going to provide links to the 2 sites that'll let you upload data or an image and listen to any data or image you want.
Love that. That's
Wow.
so perfect. Very smooth, Matt.
Seriously, I'm going to get you a job at Disney, Matt, working for the Star Wars franchise. If they ask what's next, ask them what they're going to do next.
It's a good strategy.
But actually, before we wrap up, I have a question for you, Matt, from Joe Chavez. Is the toolkit for image to sound available as open source? Because it's funny because you just said, what are you going to sonify next? Now here's the question: how?
Yeah, so there are so some of the tools I mentioned. There are some online that'll get you started right away. There's a few open source systems that for all types of different sonification. The ones I use are all custom made because I like to have as much control as possible. But yeah, if you search for online sonification or even just image sonification, you'll be able to find lots of things to get started with.
Okay. And apparently the people love you. We have another question coming in. They don't want us to ever stop. This is from Kayla Perkins. What is the best place to find the sonifications you guys do and information about understanding the process?
That's a great question, Kayla. And again, thanks for asking. You just lined them up so perfectly for us to answer. I think there will be some URLs positioned on this streaming in a little bit, but there are a couple websites. Chandra.si.edu is one of them. And within chandra.si.edu, there's a whole section on sound. You just do /sound. And you'll find the sonifications that we've spoken about and also the new ones that will be forthcoming in the coming weeks.
Excellent. Thank you guys so much. Now, before we wrap up the show, do you guys have any final thoughts you'd like to leave for the audience, Matt?
Sure. I'd just like to say, the universe is a vast, beautiful, complex place, and I think we should really be using all of our senses to experience it. While we're here, let's make the most of it, and that also lets more of us experience more of it by making it more accessible. And so I just like to ask you to, get involved, try it out. It's a lot of fun, and you get a really great response for it. So if you'd like to see, a bit more of my work, it's at system-sounds.com. But I'm really interested to see or to hear what everyone else comes up with.
Right on, right on. Kim?
Well, I can't really add much to that, but I would just say, echoing Matt's comments that really the universe is yours to discover. And there are any number of ways of doing that. Check out the nasa.gov website if you haven't already. They do a great job with social media. And of course, Universe Unplugged has a lot of great assets as well. But really, just keep looking up and keep listening.
Wonderful.